Corning single-mode fiber, model SMF28, refractive index 1.4675 at 1550 nanometers. Light in silica glass moves slower than light in vacuum, 204 million meters per second, not 299. 8 inches per nanosecond. That constant is why high-frequency trading firms pay millions of dollars for a cabinet they will never see. In a vacuum, light travels at the constant c, 299,792,000 meters per second. In silica glass, that speed is divided by the material's refractive index. For the standard telecom wavelength, that index is 1.4675. The result, 4.9 nanoseconds of propagation delay for every meter of fiber, 1 nanosecond for every 8.04 inches. In modern FPG, a tick-to-trade pipelines, the round trip from market data ingest to order emission runs in the low hundreds of nanoseconds. Fiber propagation is a first-class line item in that budget. Glass is slower than vacuum. March 22, 2024. A comment letter is filed with the SEC on Nasdaq rule filing SR Nasdaq 2024-013. The subject, cross-connect links inside Nasdaq's NY11 data center in Carteret, New Jersey. Every colocation customer runs one fiber cable from their server cabinet to a Nasdaq patch panel. From that panel, the order enters the matching engine. Footnote 13 of the McKay Brothers letter documents the actual spread of cross-connect links across NY11 tenants. 3 feet to 300 feet. The delta, 297 feet of glass, at 4.9 nanoseconds per meter, that is 444 nanoseconds of one-way propagation delay. A firm with a 3-foot cross-connect sees the book and answers the book 444 nanoseconds ahead of a firm 300 feet away, every tick, all day. The letter argues that even the smallest cross-connect differences materially impact equal market access under Section 6B of the Exchange Act. The cabinet wins before the trade. The regulatory fix is mechanical. Coil the shorter cables until every cross-connect is the same physical length. The longest cable in the facility becomes the baseline. Every other tenant gets slack fiber added, coiled inside the cabinet until physical length matches. Intercontinental Exchange Global Network Technical Specifications for the NYSE MAWA Data Center codify the policy. Quote, all connections are normalized to ensure customers have the same fiber length regardless of colocation hall or exact location within a hall. End quote. The economics are counterintuitive. A firm does not pay Nasdaq for a shorter cable. Every cable is the same length. A firm pays for the right to have its cable coiled inside the matching engine building at all. 10 gigabit fiber to Nasdaq's matching engine, $5,000 a month. 40 gigabit, $15,000 a month. Cabinet reservation, $3,000 a month. 3 years of serious colocation crosses 7 figures before the strategy prints an order. Equalized at the molecule. When every glass path inside the building is equalized, the next edge lies in a different medium. Hollow core fiber, the light path is not silica. It is air, guided by an anti-resonant photonic bandgap structure at the cladding. The effective refractive index falls from 1.47 toward unity. Propagation approaches 99% of the vacuum speed of light. 8 inches per nanosecond becomes 11.8 inches per nanosecond, a 33% reduction in propagation delay per unit length. April 2021, EU Networks and Lumenisity commissioned the first commercial hollow core link, interconnection LON1 to the London Stock Exchange, 7 kilometers of air-guided light. December 2022, Microsoft acquired Lumenisity, hollow core fiber moved from HFT curiosity to hyperscaler cloud backbone. The engineering problem for the next generation of colocation infrastructure is how to replace a silica core with a hollow tube of nothing. The next millions by vacuum. 1 nanosecond per 8 inches, 297 feet of unequal glass, 7 figures for equal access. Coming next, adverse selection and the market maker's inventory equation.